Welcome to the session. My name is Sridhar Sudarsan, and I'm with IBM. I am actually a part of the Watson. I don't know how many guys are familiar with Watson here. If you guys watched Jeopardy, it was a computer that we built last year, an expert system that actually played Jeopardy against the two champions, Ken Rutter and Brad Jennings, and won. So we're now trying to apply it on cognitive systems. So we're using a lot of Java there as well. So I just moved to that group, but prior to that, for a while, I was, and I still hold some of that responsibility. I was the chief architect for IBM's batch processing strategy. So, like a few years ago, we realized the importance of Java, importance of batch in enterprise system continuing to grow and expand. So as a result of that, I kind of took this position to look across our technologies and portfolios and System Z and distributed platforms to see how we can enable modern batch, or what kind of things we can do to enable batch systems, right? And also work with a lot of customers. So we'll spend some time today talking about why we're going to be, what's the, let me see if this works. It did when I tried it earlier. Okay, there you go. So what we'll talk about today is, just a very little time on why, batch is relevant or important and continuing to grow. I'm sure a lot of you, how many of you guys work on batch using any kind of Java today? Oh, very good. A lot of you. Excellent. So obviously, you guys probably realize why, why it's important and why it's continuing to be important. I'll touch upon a couple things, and you may or may not already be doing that. But if you're not, hopefully it'll open up, some more ways for you guys to think about how we've seen, a lot of customers using batch and how we've seen the trends across industries here. So I'll spend very little time on that, and then I'll talk a little bit about batch platform and a solution. Like, why do we need a platform for doing batch, right? And for the longest time, we've been doing batch solutions for 40 years now. IBM has been a big player, key player in that. Obviously, now there's a lot of technology changes and innovation that we want to bring into the picture. So we'll talk a little bit about that and what that entails, just from a reference model perspective, right? And then we'll talk a little bit about Java and batch. And I don't know if you guys are familiar with the fact that there is a JSR currently in place for batch. So that's something that I'll spend a little bit of time talking about that. Are any of you guys active contributors in the JSR? Okay. So we'll spend a little bit of time talking about that and kind of how that came about, and we'll spend a few minutes on the concepts around that. And then we'll talk about some of the offerings that we have from IBM around batch. I don't know if you guys use or are familiar with the WebSphere application server, which is basically a JE server. Any guys use WebSphere app server? Okay, good. So essentially we have batch capability in the WebSphere application server now. So I'll talk a little bit about what that is and how it looks like and how you can actually leverage it. And then I don't know if we'll have time. We only have an hour, but depending on how it goes, I'll see if I can quickly cover a couple of scenarios that we've actually used at customers doing batch and what that entails, and talk a little bit about some best practices, right? And the charts should be there uploaded, so you should be able to get to it. I did put some charts in the backup so that more information on the JSR, because we may not have time to go into all of that. All right. So in general, sometimes when I've gone into enterprise solutions with customers, one of the things that comes across is, well, why don't we just use real time? Why do we even need batch? Let's just move all batch to real time. Unfortunately, it's cool if you could do it, but it's not scalable. It's very, very expensive to do things real time, right? The reason you do batch is so that you get the economies of scale and the fact that you can actually optimize and make things more efficient, right? That's the biggest driver for doing things in batch, right? And that's continuing to be the case now. especially going forward as more and more, as we support and build more and more products, right? Whether you're in a bank or you're in an insurance company or retail shop, manufacturing shop, more and more products that you build, more and more channels that you support, more ways of accessing your customers, right? Growing customer base. Essentially what that means is a lot of data, right? The amount of data is growing exponentially. And in order to be able to process that in various ways, batch becomes a key component because, again, like I said, it's processing things in bulk so that you get the efficiencies, right? The economy of scale. Now, the picture is actually, I don't know if you've, it's an interesting trend that we've observed over the last few years here. Generally, we view batch as sort of being an end-of-day processing, right? Something that you do where you have a fixed time or a scheduled time that it starts and a scheduled time that it needs to end by so that, further processing, online processing can happen. Things are all updated, balances are updated, inventory is updated, etc., so that you can continue processing, more like online type transactions, right? Whether it's reconciliation and so on. Now, what we have been seeing, right, and again, this is something that is being driven by your end customers, is that the need to have access to information in a more real-time basis, right? So what that has been translating to in the back end, in the enterprise, is that your end-of-day batch, now you still need to do end-of-day in some cases, right? But more and more there are opportunities for looking at that batch window, right? And I said earlier that the amount of data that you need to process is growing significantly. The window that you have to process at night is shrinking, right? Because your clients are now becoming more global, so there's really no time that you can actually shut down or slow down your online or shut down your online and just run your batch, right? Dedicate all your resources for running your batch systems. So essentially what that is doing is that, and this is a classic problem that, when I was talking with a Swiss bank, they said, yeah, we have this shrinking time problem, right? How do we process more and more data within a shorter amount of time? Right, so one of the solutions, obviously there's a lot of ways you can address that, but one of the things that we've seen as a trend in general is to kind of do this elastic batch concept, right, where I take that whatever was at night, and I may still need to do work at night, but what I'm doing now is I'm kind of trying to trickle my batch throughout the day as well. So this whole notion of being able to run batch along with my real time, along with my message-based, all of these different processing in a 24/7 basis without affecting each other's or one another's SLAs, right? I think that's the key, and we're continuing to see more and more of that growing, right? So what that translates to is an intelligent use of the resources, the hardware resources, being able to share your logic, your business logic, right? Being able to share your people that are building these systems, so you're not building disparate batch and real-time systems, right? And one using a certain technology, another one using a different set of technologies, and so on. Just the optimization is different, right? So if you're processing a claim as an insurance company, the way you process a claim is exactly the same whether you do it for a single request and wait for a response, or whether you do it for a million of these that come in from various agents that you have, right? So the actual process that you use, or the business process or the business logic, is the same. So this is different ways of optimizing the two. What that does, there's significant benefits that you can see out of these, right? And they involve different degrees of changes. So when we were talking to a banking company, one of their core banking applications, their retail bank guys, he was like, well, if we can do this kind of changes our whole perspective on how we do our back-end banking processing. For example, today what they do is all of their core banking reconciliation of the accounts and the payments and postings and interest calculations, they do that at the end of the day because once the branches close, they send files, and then these files are then processed, and then they're ready for the next day, right? Now, instead, if we could apply something like this, what that does is now I can, now obviously the other extreme of the spectrum is to send these every single time, which is very expensive. So this is kind of a meet in the middle scenario where you're doing this throughout the day, but you're doing it in smaller batches, if you will, right? So as soon as and these could be determined by business rules. Like once I reach, $1 million of processing, I want to send it over. Or once every 2 hours, or it could change, right? And if depending on how your activity is, you could change that and optimize it accordingly, right? So you're essentially putting the control of when and how these are invoked in the hands of an expert, an SME, like a branch manager or somebody at the branch. Now, what that is doing is now in the back end, what we're doing is we're continuously processing these. And as technical people, some of the red flags that'll come up is, well, what about concurrency? What are you doing about database contention? What if you're trying to access the same kind of records? So there's that and that's kind of where we started recognizing these challenges, and we started building some solutions. So we have several ways, and obviously it's not a one-size-fits-all, right? So we have several different ways that you can actually address those kinds of challenges, right? At the data level, at the application level, at the scheduling of these jobs level, at the runtime in terms of how you prioritize one request versus the other. What you don't want is running some of these batch jobs on the same resources, and then you have a glut of online requests that come in, and you have a smaller amount of processing for that, right? So there's ways that you can actually control that, right? If there's a peak activity that comes in from your online, you can actually suspend your batch, slow down your batch, and that's why you see these varying levels of batches that you're running throughout the day, right? But essentially, the point is that you need the ability to be able to split a large job into smaller ones, stop them, pause them, resume them, collapse them together. There's all of these things that you want to do. At the data level, you want to be able to vary the amount of time you acquire the locks on the tables for, right? If you're accessing relational databases. So there's some things that we do with checkpointing in terms of how you dynamically change your checkpoint sizes depending on what kind of workload you have, right? So essentially all of these kinds of things is what we have. We kind of consider when we built this the Java batch solution, if you will, right, or the platform, and we'll talk through a lot of these things. But I just wanted to lay down the premise for this. Before we move off of this, I want to talk about one more thing, right? So I talked earlier about how people want to move all batch to real time. There's the other end, if you want to think about it from the other side, right? If you approach it from the other side, it is, I want to move what I'm doing real time today, but it's expensive, to batch, right? So what does that mean? So think about an example where, let's say you're reserving a ticket for an airline or for some concert or whatever, right? Now, when you do that, essentially what you're doing is you walk through a bunch of screens and you pick whatever you need to pick, all your options, and at the end of it, you kind of submit and make a payment. Now, typically what you expect is an email sort of comes to you within a few seconds, right? Now, you're not instantly expecting an email to come, so it's technically not real time, right? But sometimes there are these processes which do treat that request as a real-time request, and an email does come through to you. Now, if you batch up, at any given time, if you're on an airline website or a travel company website, there's probably hundreds or thousands or millions of people that are doing the same kinds of things, right? Especially if you think about like concert tickets and stuff like that. So, what if I batch these up into very, very small intervals, like 10 seconds. I collect these requests that come within 10 seconds, and I send these all at the same time, right? So I batch them up, and I send the email. For a consumer, if I'm waiting 10 seconds for a confirmation email, is that really affecting my perception of this website or this application? Perhaps not. And 10 seconds is just something that I've used. Maybe it's 5 seconds. Maybe it's 2 seconds. Maybe it's 25 seconds. But the point is that I'm really trying to, what I'm trying to make a point on here is that the key is where we were looking at things as being a continuous real-time sort of process. Now we're looking at opportunities where we can bulk them up and then gain efficiencies. Now sometimes they actually can translate to real business value as well, right? So for example, even in that ticket or account opening scenario, for example, if you're opening an account through a bunch of screens that you pass through, there's an address validation that happens, there's income validation, there's credit score calculation. There's a lot of things that go on in the background every time you click through those screens, right, from an online application. Now, imagine, and obviously you pay a third party to do that kind of stuff, right? So you pay some third party to do an address validation. Now, you do that for every single request. What if you as a business person could have a contract with them saying, look, I'm going to send you 50 of these at a time or 100 of these at a time. It's going to be easier for them to process, right? 100 at a time versus 1 at a time. So, and these 100 maybe, every 2 seconds or every 5 seconds, right? Depending on what kind of business you're in. But what that effectively does for your business is to negotiate a better contract, saying, hey, if I'm paying you $1 for every address that you're validating for me, now that I'm going to give you 100 at a time, maybe I don't pay you $1 for 100, but I'm also not going to pay you $100. Let's talk about something in between, because it's better for them. They're getting it more efficiently done, and you can get better business value out of that. So, I mean, again, the point here is that you can think about the other extreme, and some of these technologies start letting you do some of that, right? So previously the reason we didn't do it is because we didn't really have any technology to enable us to do that. So, so that's essentially what the purpose is, right? Now, some of the common batch patterns, I already talked about some of these. Especially when you're doing service-oriented architecture, when you're doing services transformation, there's a lot of need about what do you do with all your batch jobs, right? Do you leave all your batch jobs as is and you do servicification only of your, whatever is your real-time or online type applications? Perhaps in some cases, but maybe not in many cases, right? There's a need, like I said, in some cases to pull your batch jobs as well into your service-oriented architecture so that, what does that mean? You can invoke a job as a service, a batch as a service. And you can have all of a batch participate basically as a first-class workload in any process that you're creating, any choreography that you're doing of a process, right? So essentially, that's what and of course the big thing is from a SOA perspective, it allows you reuse, right? You're reusing your work, you're reusing people resources, you're reusing reducing maintenance costs, you're doing a common build, you're doing common deployment, and so on. Right, so essentially that's what you're getting here is not only just a better runtime, but you're also getting a better sort of a full life cycle model there. From a mainframe, I don't know if some of you guys use mainframe here or work on ZOS. Well, great, okay, a lot of you. So on mainframe, that's another thing that we've seen quite a bit where as some of you know, batch has been running on the mainframe for decades now, right? And one of the questions that comes up is how do I modernize what I've got, right? I mean, as my skills are dwindling about people who've written these things, 30 years ago, 15 years ago, how do I start leveraging modern technology? I still want to stay on the mainframe, on ZOS, but how do I leverage that and start being able to optimize what I've got, reduce the MIPS, reduce the cost of MIPS that I'm using today, right? Which is basically the processor speed on the mainframe, and that's how people are charged, right? So Java allows you to take advantage of some of the specially priced engines that IBM has got, which allows you to do it, a lot cheaper. And the performance actually in many cases is on par with what COBOL does as well, right? What I'm not suggesting is that every COBOL has to be transformed to Java, but there are opportunities in many cases, and a lot of customers are doing that as well, right? There's actually the biggest reinsurance company in the world, Swiss Re, which is based out of Switzerland. is actually embarked on this a few years ago, about 4 years ago, where they're running, moving their COBOL into Java, but running on the ZOS. And they're seeing an excellent benefit from a price as well as from a performance perspective, right? The shrinking batch windows, we already talked about that. From an agility standpoint, again, the whole purpose, like I said, is from a reuse. And being able to use Java as a framework, it allows you to componentize your business logic separate from how you need to optimize for batch, separate from how you're invoking your batch. And when we talk a little bit here about the reference model, it'll kind of show you how you can, obviously the more componentized your solution is, the more agile it is, the quicker you can make changes to it, and so on, right? So here's a reference model that we created a few years ago. When we started talking to customers about some of these concepts, one of the things was, well, what do you consider in batch, right? And what are the different parts that we need to think about? So again, and again, by intention, this is a reference model. What that means is, you don't need to have every single layer here, but when you're looking at your own batch applications or your batch solutions, whether it is a new one or migrating one or using an existing one that you have, it's kind of good to think about all of these different components, right, in the model. So, for example, the way to look at it, and again, given that we only have an hour, I can probably speak for half a day on this. But given that we only have an hour, I've just got this one chart on this page in this deck, and I'll quickly talk about it. But the way to read this is what you have here on the left is the development, right? What do you need from a batch application development and deployment perspective? So that includes, your tooling, your collaborative development. How do you do your team development? What kind of tooling you use for doing unit testing? How do you do debugging, builds, and so on, right? And essentially what that is it covers a lot of different best practices around doing that. What kind of tools you have available, how you can go about doing that. What are some methodologies that you can adopt that you're probably already familiar with if you work in Java, just on a regular, Java Online or J2SE or JEE kind of applications, how you can apply similar principles for building batch applications, right? So the motivation really, as we started doing all this, was me as a Java developer, I want to treat all applications alike. Batch is just one way of invoking the same application that I write, right? And online is another way of invoking the same application. So as a Java developer, I should really be abstracted from the things that are really specific for batch. As a business domain application developer. As now, there's certainly, like I said, there's optimizations you need to do for batch. And so, that's why we've got a programming model. We've got the extensions, the APIs, the SPIs that need to be extended, and you can build these fairly straightforward way, right, using POJOs basically. And the other thing that we've done, so that's your development piece. What you see on the right here is system management and operations. This once you have a batch job or a set of batch jobs or applications deployed in your environment, right? And along with your other applications that you're running, then the question, what this area covers is, how do you manage these? What kind of operations do you need? Now, chances are, if you're running a lot of batch applications in your environment today, you already have some operations and procedures and run books and so on in place. So this talks about if that is the case, then how can you keep the number of changes required, the amount of skills, the learning curve for the operators to be a minimal, right? The kind of change that they need to go through to be minimal and replicate the same experience in this new environment that we're coming through. So that's kind of what that talks about. It also talks about monitoring, scheduling from an enterprise perspective, security, how do you handle all of that, roles and responsibilities and authorization and so on and so forth, right? So that's what that's what it means by you need to think about and cover all of those pieces. The center here is, all of the center is around specifically your runtime and your applications that you're building, right? So if you look at it from top down, essentially, so given, if you think back to that picture that I showed a couple pages ago, where you have your 24/7, real time and batch or online and batch all running at the same time, what that does now is it kind of makes the notion of my batch jobs being scheduled and starting at a scheduled time kind of become less significant, right? Or not less significant, but less prevalent, if you will, right? Because now what I'm doing is I'm running these batch jobs throughout the day. There still are jobs that may be scheduled, which means they either start at a certain time or they start after a certain number of preconditioned jobs are completed, and so on. But so there's the scheduled services, but there's also these ad hoc kind of jobs that now come in, right? Which means they start because you are doing some aggregation and you reached $1 million of aggregates, so you kick off this batch job. Files come in and something else, basically they reached a certain file size limit, and then you kick off another batch job. So I mean, there's a number of different things you can think about, right? I mean, like I said, in the address validation, either when I reached 10 addresses or if I reach 5 seconds or 10 seconds, kick off a batch job at the time. So there's a number of different triggers or invocation triggers that essentially kick off these batch jobs. So you want a way to manage all of those services, right? And even if you're doing it as a part of a BPEL process, you're kicking off a batch job, then you want to know what that invocation service looks like. Because now that you're running these jobs along with other workloads, you're sharing the same system resources, that opens up other challenges, right? What I talked about earlier. How do I manage the SLAs across these workloads? In a real time transaction, if a user is clicking submit, he or she is actually just waiting for a response. You can't let that go beyond whatever your SLAs are, whether it's 90% of these users have to have a response time less than a second or so. So you cannot violate those SLAs. For batch, it's more around, it's not response time, it's really throughput driven, right? Or it's deadline driven. Sometimes it is, I need to do this as soon as possible, but I cannot exceed beyond 6 a.m. or 6 p.m. a certain time, right? Because if I do that, then I'm going to start, affecting my downstream applications. Or I'm going to miss my deadline. People, 15,000 people are not going to get their paychecks, and me as a CIO, I'm going to get fired, right? Or I'm going to pay penalties, which is even worse. So batch has their own SLAs, right? And essentially what that optimization layer does is it kind of looks at all of these different parameters, right? So how do you look at all these policies and manage the resources that you have available across all of that? So like, for example, in the WebSphere solution, there are ways where you can actually set up these kind of policies by an administrator. An administrator can set up some of these policies, and underlying applications then are running accordingly, right? Priorities are provided appropriately. Notifications are sent appropriately if you're at a risk of meeting a deadline, and so on. So, for example, if you're nearing your deadline for completing your batch jobs, then you're online and you're at a risk of completion, then maybe it's okay to kind of exceed that online SLAs still staying within your policies. So maybe your policy said 90% have to have 1 second or less, but and you're running at 98%, at 1 second or less. Maybe you kind of slow that down a little bit to give a little more capacity for your batch. Versus on the other side, if you get an unexpected, some market event occurs, and there's a lot of trading that happens, right? People are trading, or people are buying stuff or selling stuff in a retail type scenario. Then in that scenario, I want to make sure that I satisfy all of my online customers, and so I slow down my batch, right? I trickle my batch. Sometimes I actually joke about it, but it's actually true if you think about it, that a batch if you optimize your applications for batch, you technically can optimize them for real time automatically in some ways, right? Because if you think about it, your online app is, or an online request is nothing but a batch of size 1 with 0 latency. Right? I mean, if you treat it that way, then it's really all batch, right? And when I'm talking about the trickling down of batch, the other extreme of how you actually manifest itself is that, you know, I have just one record that I'm processing, and I'm not doing any latency, so I'm not preventing when I'm actually starting it. I'm just processing it straight through. So I mean, again, one way to think about, right? The container is what we'll spend, you know, some of our time here on in the next 10 or 15 minutes. Essentially, the notion of needing a container for batch, just like you have in Java, is or in online for Java, JEE, and so on, is that you're basically pushing down a lot of the repetitive work, the qualities of services that you need, down into the container and let it handle stuff, right? So the transaction services, the checkpointing, the security pieces, the thread management, priority management, all of that. The notion, the idea is, I mean, it's essentially the same kind of idea, right? I mean, 18 years ago, 15 years or 18 years ago, whenever Java came out, you know, we were all building thread pools and web containers and, you know, Java containers and transaction managers and all of that good stuff, right? But then, you know, once we decided that, well, we're all doing kind of the same things, and so we formed, you know, like the JEE specs, for example, right? And the reason for doing that was, you know, a lot of these qualities of services we could push down, and that's how we have, you know, these different containers, right? Like the app servers, essentially, that implement these. Batch, I think, was a few years behind, but we caught up, right? And same thing, we were all building, you know, a lot of you guys are doing batch. I'm sure a lot of you are doing very similar things. So when we realized that a few years ago, we started pushing these things down into a container, right? So that's what the container does. It kind of does the same thing if you think about it from a you know, EJBs or web containers. Think about this like a batch container, which basically does all of those common functionalities, provides you those quality services, and then you build your applications on top of that, right? So well, I think I have a chart on that as well. What you're doing with the data, now by definition, you're running a lot of data when you do batch, a lot or little, but you're working on data. And so the data access management services is really just your standard notion of separating your data from your application. And your data could be in any form, right? Could be files, could be queues, could be in memory, etc. Could be your COBOL copybooks, and so on. Right, and the reason you separate it from an information storage, again, that's optional, but the reason you want to separate it is because there's opportunities in a batch to do different kinds of caching to optimize your application slightly different from doing in-memory caching and so on, right? So for example, in a batch, if you know that you're operating on accounts that are from a particular branch, right, in a file, let's say you get 1 million of these, and they're all sorted by account numbers that all start with certain number of, certain way that the accounts have been defined where they all belong to the same, either type or the same location or the same zip code or whatever it is the way you can group it in. A way of caching it is to preload, whatever information you need to process, right? So transaction data, etc. for that kind of, that category of accounts. And then the life of that cache is just till you finish that batch process. So once you finish that, you flush it out and you're done. So it's a more short-lived cache, right? So there's again a number of opportunities that you start getting around how you can cache some of the information for batch jobs. And that's why we kind of separate the two, right? And there's various strategies you can apply in terms of how you do it. The infrastructure services is really depending on where you deploy it, right? Because it's all Java, we want it to be behaving similarly, but there's still, no matter how much we say that, there's still differences depending on how you deploy it and where you deploy it and so on, right? So for example, like if you deploy it on a Z system, there's some inherent advantages you get from using the Z workload manager and all of these capabilities that are already built into the operating system. Versus if you deploy it on a Linux distributed server, you get a more you get a different kind of performance, price, ability to partition your data, partition your applications, and so on. So that's just what it is when we do all of that, we build it in a way that knowing what target we're going to deploy it on, you can take advantage of some of the underlying capabilities that exist. Analytics and autonomics, it's not like predictive analytics or anything. It's really around how do we analyze the jobs that I'm running as a whole, look at the resources that I have, look at the data that I'm processing, look at the applications that I've got, the application server instances I've got, and how do I optimize it across all of that. So there's a lot of things like, at least in the WebSphere case, because you layer it in this way and you create that separation of responsibilities, there's opportunities for doing this kind of optimization. And the way, it's pretty clear because in WebSphere Batch, for example, we have built in a lot of these, and we continue to do that, right? As we learn more, as we deploy in more environments, we continue to build in these kind of automation, these kind of autonomics, so that you essentially, as an operator, it makes your life simpler. As a developer, from a tooling standpoint, makes your life simpler, and you don't have to program as much as you would if you didn't have these kind of optimizations, and so on, right? So essentially, it's about making things, abstracting things out, and providing the right kind of controls or tuning parameters to the right role, if you will, right? And like I said, there's a lot of work behind this. Maybe I took a little longer than I wanted to, but I think it's important to understand that, right? Here's a page. So we talked about how we have these different layers, right? And so essentially you have your application, and when I talk about these qualities of services and what you have within a container, essentially it's everything that you see that is not in yellow, right? Except that batch application, which is what you want to write based on the requirements you have, the needs that you have, whatever your design team is giving you or whatever you're designing yourself, that's your application. You really want, you really want to push down everything else, not from a processing perspective, processing as well, but even from a development perspective, into the container as possible, right? So you have your runtime engine. You need to have some way of managing your jobs. That's your job control language, right? And it's declarative. You want it to be where I don't have to modify any code. So think about it as being configurable, but being standardized. Some of you that are familiar with ZOS and the mainframe are probably also familiar with JCL, which is your job control language. So it's kind of a similar model, right? I mean, there is a reason why that's still so successful, right? It's very solid, it works. We're trying to adopt something very similar here as well, right? So that's how the whole declarative job definition comes up. And of course, now it's XML based. This is also there in the specs, by the way, right? And for example, in the WebSphere batch environment, we call it an XJCL, which is an XML form of providing that declarative job definition. The batch container, like I said, think about it like your any other app server container. Basically, it's doing all of that work optimized for batch. And then there's a dispatcher or a scheduler, which really manages how you dispatch the workload, how you manage different limits that you have. So you don't just bombard your system with requests as they come in, with job requests as they come in, and then cause unplanned outages and system downtime and so on, right? Logging and archival, the PJM is really parallel job manager, so it's around how you manage, parallelize your job. Remember I talked about how you can split your job into parallel streams, combine the results, all of that kind of stuff, right? Workload management, high availability, and so on. Okay. So a few minutes on the JSR. So I think we started this sometime last year. We've tried this a few times in the last few years, but last year we actually started this. You can see some of the expert membership in this community. IBM, Oracle, VMware, Credit Suisse, Red Hat, and some others. Chris Vignola, who is actually also a good friend of mine, who is the architect for one of for the Webster Batch platform, is also the spec lead for this JSR. And essentially the idea is that we took a lot of the concepts that we had, that Spring Batch had, if you're familiar with Spring Batch, and we tried to build the standards out of that, right? So what is a job? What is a job step? How do we do checkpointing? What do you do? How do you do parallel job management? What's an execution container? All of that. That's what the spec really focuses on, right? And essentially that's what we have the programming model. The target is to be Java EE or SE. I think we're delayed a little bit. The intent was to close the spec by this summer, but I think we've delayed it to the end of the year now. But there's a link. Oh, did I do that? There's a link on the charts that you can see to the community itself, to the homepage of the community, and there's also a mailing list that you can subscribe to. Right, so it's one of those. Where the proceedings are transparent, so you can actually even not only just subscribe to, but I think you can also contribute to it. Okay. So I'll spend, like I said, a couple charts on or slides on what these concepts are. So you can read the text, but essentially it is the job repository consists of a number of jobs, where each job consists of a number of steps, or it can consist of one or more steps, and there's definitions for each of these. I think you can read them there, right? And what you're doing is a job can comprise of multiple steps that always go together, right? In a certain order. They can be sequential, they can be running in parallel, but the notion of having a job and a step is that they always go together, right? So that's why you don't. You call one job and that has like 3 steps or 4 steps or 5 steps. Sometimes you may have just 1 step. The way the step is processing is essentially you have, when you execute your step, there's an item reader. So if you think about the simplest of batch jobs, what you're doing is you're reading data, you're processing data, and then you're writing something out, right? And the reading and writing are probably optional, but the writing certainly is optional. But you're reading, you're processing, and you're writing. And you do this in a loop till you run out of records that you need to read, or till you come up with an exception where you can't proceed any further. So that's the simplest of batch. Now there's complexities when you start needing to do checkpointing in between, right? You don't want to commit only at the end of all your record processing, because then if you have a failure, you have to start from the beginning. You don't want to commit after every single record, because committing is very expensive. And committing at the end of every record makes it an online transaction, right? So then there's no difference. What you're doing in a batch is you're doing a checkpoint, which means you're doing something that is between 1 and n. And typically that has been done as you do it every 5 seconds. You checkpoint on a time-based, based on time, or you checkpoint based on some records. Every time I process 500 records, I do a checkpoint, or 5,000 records, I do a checkpoint. What we also do now is we do, like I said, dynamic checkpointing. So I want to do, or I want to have my own algorithm. I want to do it time-based, but I also want to do it every time I do some kind of aggregation. Some business logic triggers a checkpoint as well. So there's that. But then the dynamic is that I keep changing it. For the same job, for the same set of records that are coming in, I want to change the way I do checkpoints. So if you think back to that picture that I showed where you run your real-time and your batch jobs throughout the day, right, with the pink and the blue arrows. Essentially, the dynamic checkpointing there is if I'm approaching now, and if you think about what the implications of doing your checkpointing at different intervals. If you checkpoint at larger intervals, then you're holding locks for a longer time. If you checkpoint at shorter intervals, you're obviously going to slow down your processing, but your concurrency is not as effective. So there's pros and cons for each, but that's where we can actually play around with some of these to see how you can, depending on what you need to process quicker or who you need to give more priority to, who meaning the online versus batch, we can actually manage some of that, right? We can do some of that dynamically. You can do that programmatically, etc. Right? And so essentially you have your item reader, your item processor, and then your item writer. And and this basically happens in a loop, like I said, right? So the operator, of course, is essentially your interface that manages all aspects of how you run your job, when you run it, when you stop it, when you suspend it, what you do, how do you manage your life cycle, and so on. Sorry about these white. I don't know if you guys can see it all the way from the back, but I should have probably made these black inside the lighter colors here. But it says job, step, job instance, job execution, step execution, chunk, and batchlet, right, if you guys can't read it from there. And essentially what it is it's showing that when you run a job, what you're actually running itself is a job instance, right? So that's your logical run. And what you're doing is, as a result of that, you're essentially executing the steps that are within that job. Now the chunk and the batchlet comes in where it's really where you're partitioning your job, you're splitting up your job, you're running these in parallel, so you're taking a chunk of your job step and you're executing it, right? And what you build as that processor that you execute in a chunk is your batchlet, essentially, right? And like I said, I'm trying to cover some of these quickly. I'm sorry because of the time, but I really want to introduce these notions to you so when you actually go back and read the specs, it'll start making a lot more sense in terms of what the context is. Chunk-oriented processing is essentially, the notion that I just talked about, right? You read an item at a time, you process it, and then you write to, you collect all these processed information and then write it out as a chunk, right? Instead of writing it out one at a time, you write it out as a chunk. And essentially, it allows you to start, again, beginning to do your optimizations, right? When you're writing every single time, you're increasing the I/O. If you collect them in memory till you can afford in the memory, and then you write it all down, push it all out in a chunk, allows you to do more optimizations. You can do some similar things in the reading as well, right? You can read it in a chunk, process it, and then write it out as a chunk. The job specification language is the job control language, right? So for those that are familiar with JCLs, it's similar to that, right? So the notion is it's a definition language written in XML to describe the job step, the data streams that you're reading from, writing to, how you're doing your checkpointing, your partitioning, your parallelization, so on and so forth. So there's a number of things you can actually describe given the schema that we have for the job definition language or job specification language. We talked about parallelization. So there's two main concepts here. One is partitioning and one is concurrent. So when you partition a job, essentially what you're doing is you're taking, if you're processing 100 records, you're taking each of those 100 records and maybe you're splitting it up two ways. So you're processing 50 in one and 50 in the other partition. And you're essentially running the same step, right? So instead of running it all in one stream, you're now splitting it up and you're running the same step for all these partitioned jobs. Concurrently running is where you're running two different kinds of processes, or two different kinds of jobs, but you're running them at the same time. So that's a slight difference between what the concurrency and partition means, right? So how you're splitting up these jobs.
Would it be data parallelism versus task parallelism?
Correct. That is right. That is another way of saying it. That is correct. Yes. Thank you. We talked a little bit about this already. So how your batch programming model flows. You have your batch controller bean, which is essentially, don't look at the bean part, right? It's essentially it's a batch controller, which is part of the container, right? And now we're getting into how this works in an implementation from a WebSphere perspective. By the way, for the JSR, I think IBM is responsible for the reference implementation for that. So we're working on that, and I think it should be out when the spec gets completed as well.
Is JSR 352 recommending running the batch processes within a container?
Correct. That is correct. So the question is JSR 352 recommending that you run run batch jobs within a container when you write in Java.
Because if I have, a Spring Java batch,
Mm-hmm.
I should be able to write, it's like almost like I'm tying my implementation to the container. If IBM is gone, then I'll be rewriting our code again for the next container that comes along.
Right. So the idea and the notion for being able to have a standard like JSR. So earlier we had our own programming model. So if you wrote, your Java batch jobs, then you run it optimized for the IBM's batch container. Versus if you wrote a Spring batch, then you're, running it as a Spring batch, not necessarily directly running it in the container. The idea here is that it's certainly a recommendation. The spec really focuses more on how you would actually have your batch job broken down. How do you best write your batch jobs? But yes, that is correct. And that is the same regardless. So the idea, the whole purpose of doing the spec is to be able to standardize on some of those programming model concepts and specify what the container should and shouldn't have, right? So it's the same thing as you would do for your online apps, right? I mean, technically you can write your own if you want to. There's nothing that prevents you from doing that. It's just that it's a trade-off between more work that you do as a programmer or as a developer because you're building in some of these services that don't exist versus building something targeted for a batch server like WebSphere. So yeah. Exactly.
Yeah, but G2E container is a lot more complex with Java batch. It's like.
It's not. It's not. Plus you can use the database and have all the transactional stuff already in there. If you just read and write directly from the database, and you can scale up very easily.
Running things within the container almost seems to. It becomes too heavy. The code becomes too tightly coupled to the container.
So actually not, yeah. You'll be surprised. I mean, if you take a look at the specs and how the applications have been written, they're not necessarily tied to a container at all. I mean, so you're barely, there's a very loose coupling between, and that's why the way the SPIs are written, the way the APIs are written, they're intended to make your code not tied so much to your app server, right?
Introducing the app server when it's not needed will not be equal to nothing.
Absolutely.
It definitely introduces some complexity.
True. So it depends. I mean, if all you're doing is just processing, something that is a script that you're using today and you're writing a Java program to do that, great, right? I mean, more power and just run it as that, and that's all you care about is running it really lightweight, and so do that.
Just like you can do it with Spring Batch.
Yeah. Fair. Yeah, absolutely. But if the idea is that you want to build something that is robust, that takes advantage of the transaction services, that is a lot more reliable, where you don't want to build all that framework yourself, that's when you use the container, right? That's when you use a batch container like this. So it's a difference. It's a standard argument that you would do even from your online perspective, right? I mean, if it's something you can do on your own, great. But if you don't want to be in the business of building all of those underlying batch infrastructure type things, the optimizations, and if you build it, it's something you build very custom to what your app is, then you have to start working on how you reuse it across your enterprise and so on. So I mean, it's the standard set of arguments that go with using a container versus can I do it on my own, right? So I mean, I don't see anything that's different here from a batch perspective. There's tooling support that exists in the Eclipse, so in the Rational Application Developer. If you guys use that, we have built in a lot of tooling. So if you used Eclipse, and you know how you say like new Java project, and basically you walk through a bunch of screens and or wizards, and it builds out the project skeleton for you, and then you go in and code. Similarly, now you can do a new batch project. It walks you through all these artifacts as wizards, and then builds out the batch project for you, right? So again, what you're adding in terms of an additional, if you're not already using an app server, you're gaining more than that from the tooling, from the time that you can use to build your application quickly, and so on and so forth. Now again, like I said, I'm not always saying that that's how it's always should be, but this is what it does for you, right? So it makes life of you as a developer, administrator, operator simpler, right? So that's what that is. This is just, I just have a couple pages on the Webster batch container. So just like you have your web and EJB container, you have your batch container as well, which, like I said, carries all this programming model jars and libraries and all of that for you, so you can essentially use it just like you build your other applications. You can share your business logic. You can share your actual application modules between batch and your online applications, right? I don't think I'm going to have enough time to run through this, but I'll just keep it for about a minute or so. The flow of a batch job is where you have multiple of these interfaces that can invoke a batch job or call a batch job, command window, another application, another service, a web service call, a job management console, which is a tool that is provided here to manage your jobs and so on. Or a WS Grid interface, which is basically your job operator interface that can allow you to interface with any of your enterprise schedulers like Tivoli Enterprise Scheduler, Tivoli Workload Scheduler, Control M, or CA7, or whatever it is that you guys use. You submit the job with the XJCL, which is the job control language. Dispatcher is a component within the WAS batch. Its purpose is to manage the life cycle of the job. We persist all of that information, so that's how you recover jobs if there's failures, or if you need to restart a job, we restart from the last checkpoint, so you're not restarting it from the beginning. The container basically is another instance of your app server. It's an app server instance where you're essentially deploying a number of your applications and managing your jobs across a cluster of servers, and you're running it against your own app's data store. Obviously, these two can reside in the same place as well. Again, like I said, I think sometimes I've spent like 2 hours on this chart, but I know I have to rush through here. The same picture as the previous one. The only difference is what we've added here is the parallel job manager. So think about the parallel job manager as being a batch job, which has a special characteristic of being able to split up an existing job that you submitted to into chunks and then run those chunks in parallel, right? So run those. So if you're processing like 1,000 requests in one that came in as one job, what this chunking can do, and again, we either have out of the box parameterizers, or you can write your own, right? How you want to chunk it, because a lot of times you don't want to just chunk it based on size or number of records or anything. You have boundary cases that you need to take care of and so on. So you chunk it, and then you submit the job over to a cluster of your containers. And what we do, right? And again, going back to some of the discussions about whether I can build it myself or use something that exists. Here, a lot of the management of the job across these chunks is kind of handled for you. So, there's a lot of conditions around what if, one record fails in one situation and the rest of the job chunks complete, and how do I recover from that, and do I have to do a lot of manual work? The short answer is a lot of that is what we take care of, right, using logical transactions. And we have this running in real financial institutions with real, actual payments processing and so on happening. So it's fairly reliable, and it's been around for a few years as well. So again, it's something you can build yourself, absolutely. Can you build something like that yourself? Absolutely. But this kind of allows you to take advantage of all of those things out of the box, right? There's a lot of cool things you can do as well around aggregating across subjobs, aggregating within subjobs, summary information, being able to provide customized status back to the caller, manually suspending some of these chunks, resuming some of these chunks. Again, to get that 24/7 allows you to do a lot of those kinds of things. So I'm going to skip that. I'm going to just breeze through 4 charts here just to show you what all you can do. So you can write these apps as an OSGI bundle. There's some interesting multi-threading capabilities that we've added in terms of how you can optimize within a JVM and across JVMs. Different kinds of job steps that you can marry together within the same job, right? Transactional, non-transactional, script-based, and so on. Overload memory protection, which is basically you don't want to kick off more jobs if you're reaching a certain heap threshold. So we have ways of preventing that. You can set those. Again, goes back to the policies that you can set, right? Just one example of that. So based on that, you don't really overshoot the amount of memory that is available on that JVM, and so you can manage that proactively. This is the tooling. Again, there's a link at the bottom, so hopefully you can go out and check it out there. I'm going to skip through these best practices. Let you stare at these customer scenarios, and I think that's my last chart. Yeah. But the customer scenarios are basically we've deployed it at mainframe customers, distributed customers, different industries, sharing batch in real time, helped manage cost, being able to make reuse a reality, and we've seen some pretty good success there. So I'll stop there and take questions.
Yeah, I was just going to say, like you said, it's there in the production environment. So what level of the spec is not complete yet? So what sort of scope of the spec is up and running in the Webster environment?
So essentially, the spec is something that has just started, right? But we have had the Webster batch around for the last 5 years, right? So there's some parts of the spec that are already in there, but because the spec is not complete, I can't say any part of the spec is really running in production, right?
So this session is over,
Yeah.
so you can take questions.
Okay. All right, so I'll take one more question, and then I'll be here. I've been told that the session is over, so I really want to thank you all very much, and I'll be around for a few minutes. So if you have any more questions.
And the presentation you have somewhere where
Yeah, the presentation has been uploaded to the Java One site, where I think where you can get all the downloads, so you can get it from there. Yes.
Oh, yeah, I was wondering if the whole idea behind this is to add processing possible. So what role does MapReduce?
You'll always have me. And if you should miss my love,